1,000 kilometers per hour. From Shanghai to Hangzhou in 9 minutes, China's first hyper-high-speed rail is coming. The cruising speed of general civil aviation aircraft is about 900 kilometers per hour. The fastest cruising speed of the Boeing 737 is 918 kilometers per hour, and the fastest cruising speed of the Boeing 747 is 1,120 kilometers per hour. Today, if you were told that a Hyperloop could run at a speed of 1,000 kilometers per hour, would you believe it? This thing is true, and it happened in China. In this video, let us learn more about it. According to Late Night News on November 16th, the main body of China's first hyper-high-speed rail with completely independent intellectual property rights has been completed. This is also the longest and largest full-scale ultra-high-speed low-vacuum tube maglev transportation system under construction in the world, with a speed of 1,000 kilometers per hour. According to Global Network, this hyper-high-speed rail is about to start testing. If it goes well in the future, it will connect Shanghai and Hangzhou, and this process will only take 9 minutes. It is worth mentioning that the high-speed flying train is the product of a combination of magnetic levitation technology and low-vacuum technology, which can achieve ultra-high-speed operation. If we want to understand hyper-high-speed rail, we must first know what Hyperloop is. The concept of a Hyperloop was first proposed by Elon Musk in 2013 when he first described his idea for a future transportation system that would send passenger pods into tubes at speeds of hundreds of miles per hour. Hyperloop is currently called the high-speed flying train in China. This is because it uses magnetic levitation technology and glides on a magnetic track, just like flying on land, hence its name. Many friends may think that this kind of transportation can drive so fast, it must be very dangerous. Not so. Fast speed is not strainy, what is strainy is the unsafe factors that affect driving. As long as the dangerous factors are eliminated, then it is safe. On the contrary, in comparison, the safety of Hyperloop is actually higher than that of high-speed rail, airplanes, and trains. Its security is mainly reflected in the following 3 aspects. First, the fixed and fully enclosed track is not easily disturbed by other things. Because the high-speed flying train travels in the pipeline and is magnetically levitated, it has no wheels and floats on the magnetic track. In fact, it is a rail transportation mode. It will not be like a train. Running around will not be affected by other vehicles, nor will it stray away from the route like an airplane. In addition, fully enclosed pipelines will not be disturbed by wind speed in nature. Second, the straight track means that vehicles do not need to turn when traveling. Because the speed is too fast, most of the routes of high-speed trains are straight. Unlike high-speed rail, trains, highways, etc. have many curves, so the risk of turning will be greatly reduced. Third, magnetic levitation drive has low mechanical failure rate. Maglev transportation technology allows trainridges to move forward on a maglev track by magnetic force. There will be no friction and vibration between the wheels and the rails like in trains or high-speed trains. The equipment and mechanical components in the trainridge will not loosen or crack due to vibration. This will make the train safer and have a longer service life. In short, high-speed rail transportation systems such as high-speed trains are safer and more stable than traditional transportation methods. Although it travels very fast, it is less dangerous and has a higher safety factor. In the future, high-speed flying trains will be used as a means of transportation between mega-city clusters. So, Are there any the high-speed flying train abroad? After Musk proposed the concept of a Hyperloop in 2013, in June 2020, a company proposed a plan to dig ultra-high-speed railway tunnels in the United States. However, Dubai has already implemented this plan. On February 21, 2018, the Dubai Roads and Transport Authority (RTA) unveiled the mystery of new technology Virgin Hyperloop. This is also the first time that the Hyperloop design has been publicly displayed to the world. With the arrival of Virgin Hyperloop, passengers can travel between Abu Dhabi and Dubai in just 12 minutes. Currently, the road journey between Dubai and Abu Dhabi takes approximately 90 minutes. The Virgin Hyperloop One system uses magnetic levitation technology to allow the capsule to slide to the ground or underground, under huge low pressure. This is the premise of Hyperloop mechanics. Virgin Hyperloop can reach speeds of 1,000 km per hour, which is 3 times faster than ordinary high-speed rail and more than 10 times faster than traditional railways. Everyone has heard a lot about the so-called magnetic levitation technology and electromagnetic technology, but what about this low-vacuum technology? It is understood that low-vacuum technology is a technology that utilizes the flow characteristics of materials in a vacuum environment for material processing to achieve low-temperature, atmosphere-free, and low-pollution material processing methods. Low-vacuum technology is a professional technical field including vacuum technology, vacuum production equipment, vacuum detection and measurement, vacuum materials, etc. The basic principle of low-vacuum technology is to form a vacuum environment on the surface of a material, and by controlling the gas pressure on the surface, the purpose of material processing and material property changes is achieved. Common low-vacuum technologies include vacuuming, isolation, gas dilution, and other methods. Vacuuming is the most commonly used low-vacuum technology. The principle is to use a vacuum pump to discharge the gas in a sealed chamber and reduce the indoor pressure until the required low-pressure state is reached. Depending on the use occasion, vacuuming methods are also divided into 2 methods: atmospheric pressure vacuuming and low-pressure vacuuming. Isolation is to encapsulate the items to be processed in a sealed environment and completely isolate them from the outside world. Under isolation conditions, the surface of an object reduces the concentration of oxygen, moisture, and other components, which can slow down and prevent the oxidation of substances and environmental pollution, thus achieving the role of protecting materials. Gas dilution is to dilute oxygen, gas, and other component molecules in the space by injecting protective gas, such as nitrogen, argon, etc., in a vacuum environment to protect materials and components. At the application level, the application fields of low-vacuum technology cover material processing, physical experiments, electronic device manufacturing, etc. For example, the optical, electrical, and thermal properties of the material can be improved by treating the material surface under low-pressure conditions, such as thin film deposition, surface modification, etc. Electron microscopy under low vapor pressure conditions provides an important experimental platform in the fields of biomedicine, metal materials, condensed matter physics, and other fields. In terms of electronic device manufacturing, high-level low-vacuum technology is one of the indispensable technical means. So, what will be the effect of applying low-vacuum technology to the high-speed flying train? According to a report from Hong Kong's South China Morning Post reprinted by Hongzhou.com, low-vacuum technology can minimize the air resistance generated when high-speed trains run at high speeds. It is understood that after the Hyperloop is equipped with a low vacuum environment, the air resistance is reduced by at least 3% compared with traditional high-speed rail. Coupled with magnetic levitation technology, it means that the Hyperloop is actually suspended in the air and running at high speed, truly flying close to the ground. As of 2022, China's railway operating mileage will reach 155,000 kilometers, and its high-speed railway operating mileage will reach 42,000 kilometers, ranking first in the world. However, China has a higher pursuit of land transportation speed. Since 2017, Chinese researchers have actually begun to develop high-speed flying trains. Compared with ordinary high-speed trains have the characteristics of high safety, low energy consumption, low noise, and less pollution. In China, the high-speed speed plan has 3 steps, namely, speeds of 1,000 kilometers, 2,000 kilometers, and 4,000 kilometers. This means that by then the operating speed of China's high-speed rail will be more than 4 times the maximum cruising speed of the Boeing 737. According to the fastest speed of 4,000 kilometers per hour, it is really possible to visit the vast country of China in just one day. Empowered by technology, high-speed flying trains have gone from floating to moving. However, before it can truly run, it is necessary to conduct speed testing on the test line by carrying out comprehensive demonstration tests of the entire line and completing full-scale system coupling integration verification to ensure that the high-speed flying train is safe on the road, travels at high speed, and operates smoothly. This is exactly the significance of the high-speed flying train speed test line verification project in Datong, Shaanxi, China. On November 10, 2023, with the completion of the pouring of the last set of module support bosses, the first phase of the main project of hyper-high-speed Datong, Yangzhou, test line, China's first maglev test line with completely independent intellectual property rights, was completed. This also marks the completion of the main project of the world's longest and largest full-scale ultra-high speed low-vacuum pipeline maglev transportation system test line. The hyper-high-speed train Datong, Yangzhou test line project is China's first full-scale test line for ultra-high-speed low-vacuum pipeline maglev transportation system. On May 24, 2021, the Shaanxi Provincial Laboratory of Hyper-High-Speed Vehicles was unveiled. The project was approved in September and construction will officially start in April 2022. The project is located in Yangzhou County, Datong City. The line is 2 kilometers long and the starting point is 500 meters west of Yangzhou South Station. In the international field, the hyper-high-speed train Datong, Yangzhou test line project has achieved many results and achieved many firsts, such as the first full-scale, full-process integration test in China. For the first time, the development and engineering system of an ultra-high-speed low-vacuum pipeline maglev transportation system for engineering applications was established. For the first time, basic scientific theories were proposed to solve the mechanics and dynamics problems of ultra-high speed and low-vacuum pipeline maglev transportation systems. Although China's hyper-high-speed train Datong, Yangzhou is only in the test line construction stage, we believe that with the substantial improvement of China's economic development and science and technology, the implementation of China's hyper-high-speed train will no longer be a dream in the future. As an innovative and forward-looking means of transportation, high-speed flying train will bring revolutionary changes to China's transportation construction and daily travel. Thank you for watching. If you enjoyed this video, don't forget to like, comment, and subscribe to our channel for more great content. See you next time.